Let's take a look at Lesson 4, Slope-Intercept Form. Remember, our essential question is why are graphs helpful? We're going to really start looking at that question in this section even more than we did in Lesson 3. Our vocabulary is y-intercept and slope-intercept form, and our Common Core state standards are 8.EE.6, 8.F.3, and 8.F.4. Now, remember in Lesson 3 we were talking about proportional linear relationships. But in Lesson 4, and this is on page 199 in your book, we're looking at non-proportional linear relationships. And a non-proportional linear relationship, the graph is going to pass through the y-intercept, which is 0b. The y-intercept of a line is the y-coordinate of a point where the line crosses the y-axis. This is different than the proportional relationships we discussed in Lesson 3, which were y equals mx, because those always pass through 0, 0. So the graph always crossed the y-axis at 0. Here, the graph's going to cross the y-axis at a different point, and we're going to call that the y-intercept. So let's go ahead and turn to page 200. All right, slope-intercept form of a line. Non-proportional linear relationships can be written in the form y equals mx plus b. So remember in Lesson 3 when we were doing proportional relationships, our form was y equals mx. We've added plus b here for the non-proportional linear relationship. This is called slope-intercept form. This is a form of a linear equation that you're going to use from now until you finish your math career. You'll be hearing about this form of an equation. When an equation is written in this form, m is the slope and b is the y-intercept. Let's turn back to page 199 for just a second. Now that we've discussed y equals mx plus b form, in the middle of your page it shows y equals mx plus b form, and it says b is the y-intercept and m is the slope. And we've already talked about m being the slope when we've talked about the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We've already said that m was the slope. So that is consistent here. M is the slope and b is the y-intercept, and then we have the point x and y. So let's go ahead and turn back to page 200. Page 200, we're looking at example 1. It says state the slope and the y-intercept of the graph of the equation y equals 2/3 x minus 4. Now they do something here that I don't do. I don't like to do plus a negative, and so we've talked about this quite often this year. If you look at this, is this 4 positive or is it negative? Well, we've said cover what's in front of it, and we can see that it is a negative 4. So there's no reason to do what they're doing here. So if we have this in y equals mx plus b form, then the slope, the m, is the 2/3, and the b is the negative 4. So the slope of the graph is 2/3 and the y-intercept is negative 4. Let's look at A. So it says do these problems to find out. Our formula, or our slope-intercept form, is y equals mx plus b, and it wants to know what is our slope. Well, our slope is negative 5. And what is our b, or our y-intercept? Our y-intercept is positive 3. So the slope is negative 5 and the y-intercept is positive 3. Let's look at letter B. Y equals mx plus b. So if we want to know what the slope is, we're looking at the number that comes before the x. Now notice that I'm not including the x in this. It's the number, or the coefficient, the number that comes before the variable. So the slope is 1/4. And the intercept, again, let's take a look at it. Is this a positive 6 or a negative 6? Well, we all know it's a negative 6, so our y-intercept is negative 6. Let's take a look at C. C is tricky for some of us, so let's look at it pretty closely. Now, we've talked about this before. What do we know about a variable that doesn't have something in front of it? There's an assumed number that comes in front of it. Let's go ahead and write it. So our m is negative 1, our slope is negative 1, and our y-intercept is positive 5. So don't let that throw you. Don't put negative or negative x. Remember that we assume a 1 here. Okay, we're always going to assume there's a 1 in front of any variable that does not have a coefficient. So let's look down at example 2. It says write an equation of a line in slope-intercept form with a slope of -3 and a y-intercept of -4. So we know we've got an m of -3 and a y-intercept of -4. And we know that we're going to put our equation in this form, y equals mx plus b. So y equals m is -3x and b is -4. So our equation is y equals -3x minus 4. Those are pretty easy to do. And again, notice that I did not use this because I don't like that plus a negative. And I like to just go and realize that -4 makes this -4. Number 3 is asking us to interpret the graph and to get our equation from the graph. Well, we've already done this to an extent when we've looked for the slope in other lessons, but here we're going to look for just a little bit more. So the first thing we're going to do is we're going to find our slope and our y-intercept. The y-intercept is the easiest thing to find because that's where the graph crosses the y-axis. Remember, the y-axis is the vertical. So we start at 0 and we count up 1, 2, 3, 4. Because we counted up 4, our y-intercept is +4. Now, remember that we start at the left point and we're going to count until we get to the next point to find our slope. So here we're going down 1, so remember that it's going to be rise over run. And if we go down 1, that's our rise, but it's negative. And then we're going over 1, 2, that's positive. So we have a slope of -1/2. So our formula, or our form of the linear equation is y equals mx plus b. So we'll put in what we know, y equals -1/2 x plus 4. And that would be our equation from the graph. So remember, step 1, find the y-intercept. All right, we can write that here. Step 1, find y-intercept, which we know is b. And step 2, find the slope. And we know how to do that from previous lessons, and the slope is m. Let's go ahead over to page 201 and look at the examples at the top. So it says in D, write an equation in slope-intercept form for the graph shown. So we said step 1, okay? Step 1 is we're going to find the y-intercept. And that's our B. So we're going over to our graph, and to find the y-intercept, we look where the graph crosses the y-axis, and it's going to cross the y-axis at -2 because we went down 2 on the y-axis. And then we're going to count from here to find our slope. So number 2, find the slope. And remember, we start at our left point. We find our rise first, so m equals rise over run. So we'll go up 1, 2, 3, 4, 5. So our rise is 5, and our run is 1, 2, 3. So we have 5/3 for our slope. And then we're going to take y equals mx plus b form, and we're going to fit in what we know. So we have y equals m is 5/3, and b is -2, so -2. So our answer would be y equals 5/3x minus 2. So it's not difficult. This is step 3, write the equation. But you do need to follow the steps and pay attention to what you're doing to find the slope and the intercept. So let's look at E. It says write an equation of a line in slope-intercept form with a slope of 3/4 and a y-intercept of -3. So here's our slope, 3/4, and here's our y-intercept, -3. We'll write the linear form of a linear equation, slope-intercept form, and fit in what we know. 3/4 x intercept minus 3. So y equals 3/4 x minus 3. So hopefully you were able to figure out how to do those from what we just did. We'll do some more examples together in a little while, but if not, go back and review what we've done so far. If you've got it, let's move on to interpreting the y-intercept. It says when an equation in slope-intercept form applies to a real-world situation, the slope represents the rate of change, and the y-intercept represents the initial value. So this is going to be important because when you're actually interpreting graphs, it's important that you understand that the slope's going to be the rate of change and the y-intercept is going to be the initial value or where you started. So let's look at number 4. So student council is selling t-shirts during Spirit Week. It costs $20 for the design and $5 to print each shirt. The cost y to print x shirts is given by y equals 5x plus 20. Graph y equals 5x plus 20 using the slope and y-intercept. Well, the first thing we're going to do is find the slope and y-intercept. So we have the slope is 5, here it is, and the y-intercept, or the b, is 20. Here it is. Graph the y-intercept. So the y-intercept, we're going to find it's going to cross the graph. It means it's crossing, the equation crosses the graph at 20, so they've put a dot there for us. And then it says to write the slope as a fraction, so we're going to take 5 and write it as 5/1, and we're going to use it to locate the next point on the line. So notice that the y-axis goes up 5 already, 20 to 25, so we're going up 5 and to the right 1, and we'll draw another dot. Go up 5 to the right 1, up 5 to the right 1. I generally like to have 3 or 4 points to make sure that we're okay. So now we've graphed the line. So it says interpret the slope and the y-intercept. The slope 5 represents the cost in dollars per t-shirt. The y-intercept 20 is the one-time charge in dollars for the design. So no matter how many t-shirts you get, it's going to cost $20 for the design, and then your unit rate or your rate of change is $5 for every t-shirt that you purchase. Let's go ahead and turn to page 202 and look at the top. It says a taxi fare y can be determined by the equation y equals 5/10 x plus 3.5, or 3 5/10, where x is the number of miles traveled. Graph the equation and then interpret the slope and the y-intercept. Alright, so remember that when we graph the equation, we're going to go up on the y-axis to the y-intercept. When you look at your equation, y equals 5/10 x plus 3 5/10, we're going to notice that our slope is 0.5 and our y-intercept is 3.5. So y-intercept of 3.5 takes us halfway between the 3 and the 4, so we'll put a dot right here between the 3 and the 4. And then we're going to go up 1/2 and over 1, because remember we had to make our slope into a fraction, so we're going up 1/2 over 1, up 1/2 over 1, up 1/2 over 1. And then you're going to take a straight edge. I'm going to use a piece of paper today because I don't have my straight edge with me. And we're going to draw our line and put an arrow on the end of it. So now it tells us interpret the slope and the y-intercept. Well, in this case, the slope is the charge per mile, which is 50 cents per mile, and the y-intercept is a flat fee of $3.50. So if you've ever ridden in a taxi, you would know that generally from the time you step foot inside the taxi, there's a fee no matter how far you go, that you pay, and then you pay per mile after that. So that's what those two things mean. All right, let's take a look down at the guided practice. What I would like for you to do is I would like for you to attempt to do number 1 and number 2. So 1, all 3 parts. We're going to state the slope and the y-intercept of the graph. Remember, here's your equation, so this is where you're going to get your information from. You're going to graph the equation, and you're going to interpret what the slope and the y-intercept represent. And then I want you to do number 2, where you write an equation in slope-intercept form for the graph shown. When you get those finished, bring those to class, and we will go through them together and go over any questions that you have.